Welcome back, class. Thank you for joining me for 4-5. Today we're going to move on to doing more with these quadratic equations. So far, all we've been doing is working with quadratic expressions, graphing them, factoring them. Well, today we're going to learn how to solve them. So solving a quadratic equation, we're going to be working with a generic equation of this form, ax squared plus bx plus c. And to solve it, we're going to have it equal to 0 and then figure out what the x's are. Now, something I want you to understand, if you look at the graph there, when we're looking for the solution to a quadratic equation, what we're actually looking for graphically are the x-intercepts, where it crosses the x-axis. So that means there are a lot of different words I can use to ask this. I can ask you for the zeros of the function, the roots of the function, the solution to the function, the x-intercepts of the function. There's a lot of different ways I can word this, but all of them are getting at the same thing. You're trying to find where does the graph cross the x-axis. Now, we all know graphing isn't the most accurate way to do this because if it's not a nice number, you really can't tell what that solution looks like. So instead of focusing on the graphing portion, what I want to do is I want to focus on the algebraic methods. Now, the first algebraic method we're going to focus on is what's called the zero product property. Okay? Now, zero product property, what that says is in order for two things to equal or to multiply to equal 0, at least one of them has to be 0. The only way two things can multiply to be 0. One of them actually has to be 0. So, in terms of these quadratics, what does that mean? Well, that means when I see something like this, all right, that is a quadratic, all right? Now, what it means is when I see a quadratic in that form, in factored form, what I can do is take those pieces, and it's telling me, all right, one of those pieces, so either that x plus 5 has to be 0, or the x minus 7 has to be 0. At least one of those pieces must be 0 in order for it to multiply for the whole thing to be 0. So what does that mean? Well, that means x equals -5 and x equals 7. Those are going to be my two solutions. So again, graphically, if we were to graph it, those 2 points would be where it crosses the x-axis. Notice crossing at 2 points. Crossing the x-axis twice represents two solutions. Now, our next example is essentially the same thing. 2x minus 3 times 4x plus 9 equals 0. I'm going to take both of those pieces. I'm going to take that 2x minus 3, set it equal to 0. Then I'm going to take that 4x plus 9 and set it equal to 0. You take both parentheses and set them equal to 0. And now you solve them. So that 2x minus 3, well, I'm going to add the 3 over, and I'm going to divide by 2, which gives me x equals 3 halves. On this side, I'm going to subtract the 9 to the other side, and I'm going to divide by 4. So that's how I get my two solutions here. Those would be the 2 points that the graph would cross the x-axis. Now, when you're solving these, notice I just left them as fractions, all right? Don't bother turning them into decimals. Some of the decimals would get a little bit nasty. So just leave them exactly as is, as the fractions. Now, those are very idealized cases, all right? Those are in a form you can already use the zero product property on. So I'm going to move on to some examples. What if I give you things that look like that? Now, those are what we normally think of quadratics as, and they're not in factored form. However, the good thing is we've spent 3 days reviewing factoring, and this is why. Because if you see a quadratic like this, you absolutely must factor it and then do the process that I just showed you. So what that means, if I'm going to factor this, first, I need to look for the things that give me the x squared. Well, x squared comes from x and x. Things that multiply to 6, that's going to be 1 and 6, 2 and 3. And the other thing that I notice, they are combining, they're adding to be a negative number. All right, so what that's telling me is that I need two negative numbers. That's the only way that they're going to still multiply to be positive and add to be negative. So if I'm looking for two negative numbers, I'm going to go with 2 and 3. And again, just to check to make sure I've done this right. That connection gives me negative 2x. That connection gives me negative 3x. Yep, that gives me the negative 5x that I was looking for. So I've properly factored it. Now, that is only part of the work of this section. Okay? Once you have it factored, we still have to actually solve this quadratic. Now I'm going to apply the zero product property. I'm going to take both pieces, both parentheses, and I'm going to set them equal to 0. So I get my first solution of 2, my second solution of 3, and now I'm done. When the instructions are to solve, I should be getting legitimate number answers, numerical results. All right, looking at the next one. Now, the next one, if you notice, that's one of our special cases, because notice there's only two terms in that, all right? And that 100 and the x squared, that should kind of get you thinking perfect squares, right? 100 was one of those special numbers where x squared, remember square root of x squared is just x. Square root of 100 gives you 10. So remember, when you have one of those cases, you are subtracting two perfect squares. That's one of our special cases. We have that plus and minus relationship. So we get x plus 10, x minus 10, and boom, we are done already. So don't forget, even in this section where we're solving, those special cases will still show up. Now, once I have the factored form like that, remember, I'm not done. I need to go from there. Now, I need to set each piece equal to 0. So, subtract 10 from that side to give you an answer of negative 10. Add 10 on this side to get positive 10. And those are your two solutions. Those are the two places that the graph would cross the x-axis. Now, there is another detail that I need to discuss with you. So, the quadratic equation must be set equal to 0 in order to factor and solve for the zero product property. So if it isn't set equal to 0, you have to move everything to one side of the equation yourself. All right? So what does that mean? Well, in this first example, notice I have 3x squared plus x, but that it's set equal to 14. It's not set equal to 0. So what I'm going to do is I'm going to take this and I'm going to move the 14 over. I'm going to subtract the 14 over to be with everything else. Because now I have something that is equal to 0. I have something that I can legitimately solve. So if I'm being told to solve by factoring, I need to be getting my two parentheses. Now, to get 3x squared, how do we get 3x squared? Well, that means this is going to be 3x and x. Negative 14, well, that's 1 and 14, 2 and 7. Now, recall, the way that I'm going to be able to get a negative 14 is one of the numbers in the pair must be negative. So I need to keep that in mind when I'm putting these in, that one of my numbers is going to be negative. So we need to start looking to see what can we form to get here. Now, I'm going to start with the 2 and the 7, all right? I'm going to decide I want to start there. So, I have 2x here, 21x there. Now, even if I make one of those negative, I'm not going to get the 1x that I'm looking for. Make one of those negative, I'm either getting 19x or negative 19x. So not quite what I'm shooting for. So I'm going to have to try something different. Now remember, if that doesn't work, just reverse them. All right, that's the next step. So I'm going to put the 7 here and the 2 there. Let's see what happens now. I get 7x and I get 6x. Well, this is looking a lot more promising because if I need to make one of those negative and I want the result to be a positive 1x, I can make this the 6x negative because 7x minus 6x is 1x. So I follow that up, so that means I'm going to put the negative with a 2, positive with a 7. And that's going to be my factored form. Okay? But recall, just factoring this isn't the end of the problems anymore. We're actually being asked to solve these. So once you have it factored, remember the solution is taking both of those parentheses and setting them equal to 0. So for this first one, I'm going to subtract 7 from both sides, then divide by 3. And remember, just leave it as a fraction. Then on this other side, I'm going to add 2. Those are my two solutions, the 2 points where I would be crossing the x-axis. All right, next one, same thing. Right now, we have 2x squared plus 7x equaling 15. We don't want it equaling anything but 0. So what am I going to do? I'm going to move that 15 over. I'm going to subtract it over to the other side. So now I have my quadratics that equal to 0. Now I'm ready to factor and solve. So to put this in factored form, how do I get 2x squared? And the only way to get 2x squared is if this time I have 2x and x. Shooting for 15 is 1 and 15 or 3 and 5. All right. And again, notice we're multiplying to a negative 15. So I know right off the bat, one of the numbers in those pairs is going to have to be negative. Now, using number sense, I'm going to start with a 3 and 5 again. Okay, I'm going to start with my second pair just to try that one out first to see if I can get it to work. So I'm going to plug in my 3 and my 5. And I'm going to check to see what I have. I have 3x there and 10x there. So again, we already talked about one of those is going to be negative. So making one of those negative, can I get a positive 7x? The answer is yes, I can. If I have negative 3x, those are going to add to positive 7x. So that means my negative goes there, positive goes there, and that's going to be my factored form. So I'm going to erase that. And now remember, that's only part of the battle here. After you factor it, you need to set both pieces equal to 0. Once you've done that, now we just solve. So on this side, I'm going to add the 3 over and divide by 2. On this side, I'm going to subtract the 5. And there you have it. Your two solutions are the 2 points where the graph would cross the x-axis. So thank you so much for joining me. Please make sure you have all these notes written down, and then we will continue with the practice work in class.